file input output or file handling in C language. So the objectives of this video lecture or lecture video or this video is for the user to be able to know how to open files, how to close files, how to write into a file, and how to read a file in C language. Opening files. In opening files in C language, we use the fopen function to create a new file or to open an existing file. So the format is with the file data type, we have fopen and then constant character or the file name followed by the mode. So file name followed by the mode. For modes, these are the modes that we can use. R is used to open an existing text file for reading purposes. We use W if you open a text file for writing. If it is not, if the file does not exist, then a new file is created. We use A, so it is actually similar to W, so opens a text file for writing, but for A, it is in a pending mode. So if you use W, you will be overwriting the whole file, but if you use A, then you will just be appending data at the end of the file. So similar to W, but you are here to your program start appending content in the existing file content. We can also use R+. So R+ opens a text file for both reading and writing. W+ opens a text file for both reading and writing, but it first truncates the file to 0 length. So if it exists, so it will overwrite the whole file, and then otherwise create a file if it does not exist. A+ is similar to W+, but does not truncate the file to 0 length. Writing can only be appended. For binary files, but it will not be covered yet in this video, we use RB. So just read, write, and append, but we just add the B. So others will be similar to this, but instead of text file, we'll be reading binary files. How do we close a file? So to close a file, we use the fclose function. So format is fclose followed by the file name, or actually the file handler. To write into a file, we use the following functions. So we have the fputc. So fputc, and then we have here the character, and then we have here the file pointer or the file handler. The function fputc writes the character value of the argument C to the output stream referenced by the file fv. So we just write a single character. fputs, so similar with this one, but instead of just a single character, we write a whole string. So that's just the difference. So the function writes the string S to the output stream referenced by fp. fprintf is also similar to fputs, but with different syntax. So we have the file pointer first, and then we have the string. So similar to if fputs. Reading a file. So to read a file, we have fgetc. So we have the file reference, and then so using fgetc reads a character from the input file referenced by fp. So if we have fgetc, we also have fgets. So that returns a string. So this one returns a single character because we read a character. As we have here integer. Here we have character, a pointer character. So that means it is actually a string. So we have here character, and then we have the number of the buffer here, and we also have here the length or the maximum number of characters, and then the file reference. So reads up to n-1 characters from the input stream referenced by fp. If the function encounters a new line, so that maybe it's a \n or enter key in the text file, or the end of the file euf, before they have read the maximum number of characters, with this n here, then it returns only the characters read up to that point, including the new line character. fscanf is similar to fgetS but stops reading after encountering the first space character. So in summary, before we have our short or our demo, actually we have several demonstration programs. We use fopen to open file, fclose to close files, fputc, fputs, and fprintf to write to a file. And we use fgetc, fgetS, and fscanf to read from a file. So let's now have a short demo. So allow me now to open the devc. And then we create a new project. So new project, console C project, file IO demo. Let's call it file IO demo. And then, okay. I'll be creating a new folder, file IO demo also. So we have here now our new file. So what I'm going to do now is I'm going to open a file handler. So file pointer. So file fp. So I'm going to open a file. So let's say I want to name the file as text for writing. So let's just use W plus. But that's only for writing. We can also use W if you want. So we try the two methods. So we have printf, that's one method. So we have fp. Then we have our string here. So this is a test for printf. Then we have \n. So what this will do is to write this string into this file. So this is our file folder, if you still remember our syntax. So another way is to use fputs. So in fputs, we have the string first. So fputs. Then we have here now the file pointer. And then we close the file. Okay, so what we did here, so we have here a very short program. We created the file pointer using the file data type, and then we open the file for writing. So we have W plus, we can read and write, but here we only want to write to the file. So printf, so this will be written to the file using this format, and then fputs this will also write this file text or this string into this file test.txt. So let's try to run the program. Okay, so we don't have any, but let's try to check. Let's try to check our folder. So file IO demo. You notice here that we already have this file test.txt. So this is the file that was created by this program. So I'm going to right click and maybe edit with Notepad++. So this is our output. This is a test for printf. So this, since we have a \n, this test for f put s. So it created that text file. So let's just leave that open. By the way, I just would like to make the output bigger. So this is our output because that is what we have specified here in our program. Okay. So now let's have a demonstration to read the text file. So I'll be erasing this one now. So this time around, again, I have the file fp. I'm going to create a buffer or some space where I can read the text file or the text from our text file. So fp equals fopen. So we use test.txt. That's our file name, right? And then we're going to use this now for reading. So our mode is R. So a while ago we used W for writing. Now we're going to read. So we use R. Scanf. So we're going to read the string and place it in buff, the buff variable. Okay. So after reading that, let's try to test printf. So this is our first statement. So we print s and then \n buffer. So what we did here is to open the file for reading. Then we use scanf rather, using this stream or this file, and we're going to read a string. So this will end after we end a space, encounter a space. So if that's the case, that will read only this. So that's the first one, and then what we're going to do will be placed in this variable buffer. So what we did here now is to print what is the content of the buffer. So we are expecting that this will just print this. And then let's now try get s. So we just cast fp so that it will use this data, this format, file pointer fp. So what will this do is to read with a maximum of 255. So since we already have read this one, this will just continue reading on the next pointer or the next data. So up until it encounters a new line or maybe the end of file. So after reading that, we print. This is the second statement. So we have \s, \n, buffer. Okay. Then we use get s again. It's similar with the first one. So in the next one, we use again the same format, and this is our third statement that will read from the text file. So let's check. Do we have wrong spellings here? No, no, no. Okay, so let's run the program. That's our output. Okay, so let's check. Why is this our output? The first one is we have your f scan f %s. If you still remember, this will stop reading after the first space is encountered. And this is our data file. So if space is encountered, then it will stop reading, so it will be able to read this only. So that's the difference. Or if we use f scan f, so buffer. So this will read this. Then the next one, if we use again f get s, it will just continue to the next with the next character. So we have here backslash and buffer. So in this statement, it will stop until a new line is encountered. So in this case, up to the end of this line. So if we notice here, our output is a test for f print f. And then the next one will again do the same, but this time, since we don't have our initial line, it will read the whole line and place it in buffer and place the output. So it will read the whole line and here printed in our output. So we have here now our two demo programs. Now I'll be showing you another demo program. So I have here already done this a while ago. So I have here read CSV. I created a CSV file. Actually, a CSV file is just so it can be opened using Microsoft Excel. But actually, you can create it using text file and just separate each item with comma. That's why it's a CSV file. Okay, so let me now open my program. So here's our program now. So in this program, I created a function that will get a field. So I will open our CSV file. So read CSV. This is our CSV file. I'm going to open it using a notepad. So that is a CSV file. Okay. So in our program, I will be opening a file. So I will be opening that file, data.csv, and then I'm going to read each line until this becomes null. That means it is end of the line. So after reading each line, I just duplicated the line into temp, and then here we get the field from each line. We get the field from each line. Actually, the first two fields only. So field 1 and field 2. So which are actually the number and the name. So the number and the name. Then we just free the memory. Then we repeat this until we reach the end of the line and then close the stream. Now what's the get field function? The get field function, we just do something like this. So we're going to read the whole line, this line, but we want to separate each of these items, and each item is actually called a token. So that is what this function will do. So it will read the line, and then so after reading the line, we have here our temporary variable, the tokens. So this will be our output, actually almost similar to token. And then token, we get the first token. So this will just get the first token. So actually that will get, in this case, this one, until the time that we reach, where's my program? We reach that number. So if that's already the number, it goes out, and then the token we have is placed on temp. If not yet, go get the next token. So this will get the next token until the time that we reach the number we specified here. And then we return the token. So token equals temp, that is returned here. So if we have field 1, this will first return the first token, and then 2 returns the second token from this variable here or line. Okay, so we open the file, read the line, get the token, and then close the file. So I execute, compile and run. So you notice we have here our first token, the number, and then we have here our names. So we can add here. Let's say let's add more. 555. Another one. So then we save the file.